Okay, welcome back to this concept based YouTube channel. Today we're going to discuss about question number 1 of exercise 1.3. So this is a kind of distributive expansions, or we have to express this fractions or this rational number in the form of distributive expansions, and then we have to check whether it is belong to terminating or non-terminating distributive expansions. Okay, so for that, let us proceed to the first question, or to the first Roman number, that is 36 by 100. Okay, 36 by 100. Here let us write exercise 1.3. So the first question that we have is, that is 36 by 100. Okay, so just divide 36 by 100. Okay, so here let us add one more zeros, so that means 100 times 3 will be 300. Here 60, here at this point, then we can add more zeros. 100 times 6 will be 600. Okay, here this is 0, so that means the distributive expansions that we get, it terminate at digit, it terminate at this digit. Okay, so this kind of distributive expansions that is terminating is known as terminating distributive expansions. Okay, therefore it is a terminating, terminating decimal expansions. Okay, then we have to move it to the next question, that is number 2. Okay, so here it is 1 by 11, so I have to divide this. So in order to do this, how should we do? Just divide 1 by 11. Okay, so here let us set point, then it will be 0. Here it is 0, so if we add more zeros, then we can add zeros. Okay, 11 times 9 will be 99. So 100 minus 90, that will be 1. Here it is 0, here it is point, and then we can add zeros. Here we can add more zeros. Okay, so 11 times 9 will be how much? 99. Okay, 100 minus 99 will be 1. Okay, therefore what is the distributive expansions that we got? That is 0.09. Actually the remainder is not 0, is non-zero, then the distributive expansions will go on like this. So we can represent in short form this distributive expansions as 0.09 bar. So this kind of distributive expansions which never end, or repeat itself after this digit again and again, is known as non-terminating recurring distributive expansions. Okay, thus it is a non-terminating recurring decimal expansions. Okay, all right, then let us move to question number 3. Here we are going to solve, that is now Roman number 3. Okay, so in Roman number 3, what number that we have, or what rational number that we have, that is this number. Okay, here 8 times 4 will be 32, 32 plus 1 will be 33 divided by 8. Okay, so in order to get distributive expansions, you have to divide 33 by 8. So 8 times 4 will be 32, 33 minus 32 will give you 1. Here at this point, let us add zeros. So 8 times 8 times 1 will give you 8. 10 minus 8 will be 2. Here at this point, data set, how much? 8 times 4 will be 32. 33 minus 32 will be how much? 1. So we add point. So 8 times 8 will be 8. 1 are 8. Okay, 10 minus 8 will be 2. So here at this point, we can add zeros. So 8 2 are how much? 16. So 20 minus 60 will be 4. Here at this point, then we can add zeros. 8 times 5 will be how much? 40. Alright, so here the remainder becomes 0. That means here it is the end of this distributive expansions. This kind of distributive expansions that end at some numbers or some digit are known as terminating distributive expansions. Okay, 4.125. Therefore it is a terminating terminating decimal. Decimal expansions. Okay, so that's it. Let us move to number 4. Okay, that is Roman number 4. So in Roman number 4 we have 3 by 13. Okay, so in order to get decimal expansions, same as the process that we did in the first, in just before this we have to proceed it here also. Okay, let us set zeros. So 30 minus 2 will give you 26. 30 minus 26 will be 4. Okay, here at this point let us set zeros. 30 into 3 will give you 39. Okay, so 40 minus 39 will be 1. Here at this point let us set zeros. Okay, so a little bit less than this. Okay, because of that we can add more zeros. Okay, if we add zeros then it will become 100. 30 into how many times will give you 100. If we didn't get that exact values of 100, then we have to take the number that is much closer to this. Okay, 13 into 7. Okay, 13 into 7 will give you 91. Okay, 100 minus 90, what will be? 10 minus what will be 9. Here it will be 9. Okay, so that's it. Then here at this point we can take zeros again. So 13 into 6 will be how much? 6 3 are 18. 6 1 are 6 7. Okay, that means 10 minus 8 will give you how much? 2. Here there will be 8. 8 minus 7 will be 1. Okay, so that is 9 7. 8 minus 7 will give you 1. Okay, that is 12. Then let us move here at this point. Then we can add more zeros. Okay, 30 into how many times? 9. Let us take it. 90 are how much? 27 2. 91 is how much? 9. 91 is 9. 9 plus 2 will be how much? 11. Okay, that is 117. So likewise you will have to proceed it. Okay, if you don't get the decimal expansions, whether it is terminating or non-terminating, then you will have to proceed it like this. So after this we have to do it actually the decimal expansions that we got, it goes on like this. Okay, it goes on like this, and we have to check it whether it is terminating or non-terminating. Then we have to add 9. So how much will it be? Then the 117. Okay, so 10 minus 7 will be 3. And then what will it be? This. Okay, the same process will repeat after this decimal expansions. Okay, so this will represent the decimal expansions, or the digit under this is repeating itself after this. Okay, what can we write? It is a non-terminating. It is a non-terminating recurring. Okay, or repeating recurring decimal expansions. Okay, all right, then we're going to move it in question 5. 5 solution. So in question number 5, what does we have? That is 2 by 11. So 11 2. So here it is point 11. What is 11? 29. Okay, so here it is point, let us add zeros. 11 8 are how much? 88. So 90 minus 88 will give you 2. Okay, so here it is. Actually after this, okay, after this the same decimal or the same digit will repeat itself again and again. So this is the decimal expansions belong to non-terminating recurring decimal expansions. Okay, therefore 2 by 11 equal to how much? 0.18 bar. Okay, hence we can write it as it is a non-terminating recurring decimal expansions. expansions. Okay, then we are going to move it into number 6. And number 6, we have what? We have 329 divided by 400. Okay, here it is how much? 400 into 329. Let us set 0.0. Okay, here how much will it be? This one, and 90, here it is point, so we can give it as 2. 400 times 2 will give you 800, so how much will it be? 100. Here at this point we can add more zeros, so 400 times 2 will give you 800, so 1000 minus 800 will give you 200. Here at this point we can add more zeros. 400 times 5 will give you 2000. Okay, so after this the remainder will become 0. That is the end of this simple expansions. Okay, this kind of simple expansions that end at some number are known as terminating simple expansions. So we can write it, therefore it is a terminating decimal expansions. Okay, that's all for today. So this is the last portion. So before we close this explanation, let us move to, or let us review to the problem that we have done just before this. Okay, then that's all for today. Thank you. We'll see you in the next class.